All right, my little math friends, we've got lesson 10-4, X and Y intercepts. Our question today is, how can we find the y-intercept of a quadratic function? Good question. So when we're graphing, here we got a linear equation. So if we graph this, our y-intercept's -4, so down 1, 2, 3, 4. And then the slope here would be 2, so that's 2 over 1. So we'd go up 2 over 1, up 2 over 1. There we go. We've got our nice little graph there. And boom, there was our graph. Now, when we're talking about intercepts, we are looking at this is the y-intercept, and this is the x-intercept. So the x-intercept is where the graph crosses the x-axis, and the y-intercept is where the graph crosses the y-axis. So here I had my x-intercept of 2, 0, and here I had a y-intercept of 0, -4. Now notice when I crossed the y-axis, the x value is 0. So I got 0, -4 for the y-intercept. But when I crossed the x-axis for my x-intercept, the y value was 0. So that's always going to happen. Your y-intercept is always when x is 0. Your x-intercept is always when y is 0. So it's when the opposite letter is 0, that's where you're getting your intercepts from. Okay, graphing this other one. If we graph this other one, we could tell that our vertex, since it's in vertex form, would be 3, because we take the opposite, -4. So I would go over 1, 2, 3, and then down 4. I think that's right about here-ish. Does that look good? Somewhere around, let's take that bottom one right there. All right, and that would tell me that my axis of symmetry goes right here. All right, let's be smart about getting the rest of my graph. That does not look straight at all. Just pretend it is, okay? Anyways, I'm going to I'm going to plug in some other points and use the axis of symmetry. So I've already got x is 3 right here, right? So let's plug in 2 to find out where it is over here. So 2 minus 3 is -1. -1 squared is +1. And 1 minus 4 is -3. So if I plug in 2, I get -3. Now that tells me since I have an axis of symmetry here, I should have another point on the other side. So I automatically get that one. It's 2 for 1. Once you get 1, you get the other one. Okay, the next number I would plug in, I've already plugged in 2, and I got -3. Let's plug in 1 and see what we get. So I'll do 1 minus 3 is -2. -2 squared is 4. 4 minus 4 is 0. I get this point here. And that tells me since we have the axis of symmetry, this is 2 units away from the axis of symmetry. That means 2 units away over here, I'll get another point because they are a reflection over that axis of symmetry. And so we get this graph right here. Now, if I were to keep on plugging in points, like say I wanted to plug in 0, if I plug in 0 here, 0 minus 3 is -3. -3 squared is 9, and 9 minus 4 is 5. So 1, 2, 3, 4, 5. There's another point there. See, I didn't do a very good parabola, but we're just going to pretend I did. All right, so there's our parabola right there. And we would get another point over here as well. Delicious. All right, so what we see here, there's a little bit of a difference. I do get one y-intercept right there. There's my y-intercept. My y-intercept is at 0, 5. But for my x-intercept, I get 2 different x-intercepts. I get one right here and another one over here. So this is an x-intercept, and that is at 1, 2, 3, 4, 5. That'd be at 5, 0. And I get a second one over here, bonus, at 1, 0. So the difference between a linear equation and a quadratic equation is I can get multiple x-intercepts on a quadratic because it changes directions and I can cross the x-axis more than once. But I'm still only going to get one y-intercept. All right, so an x-intercept, what is it? It's where the graph crosses the x-axis. So we saw here that it crossed the x-axis. And we know that y is always going to be 0. So anytime I had an x-intercept, y was 0. Over here, x-intercept, y was 0. So every time we have an x-intercept, y is going to be 0. Now, this was just one of the possibilities of things that could happen with a quadratic. There's actually 3 separate possibilities of things that could happen if you have a quadratic. Possibility number 1. We can have 2 x-intercepts. That could be a situation, stupid lights, come back on. Lights, there we go. I was not moving enough. All right, so that could be 2 different situations. I could have a graph here, and just like that last problem, I could do something like this and get 1, 2 x-intercepts. Or I could have another graph, and we could have a frowny face graph. I don't think they're really called frowny faces, but we're just going to do that anyways. So we've got right there. So this one faces down, but it still has 2 x-intercepts. So that's the first possibility. I could get 2 x-intercepts. But I could also get just 1. So how, you say? If I get 1 x-intercept, how would that happen? Well, what if I had a graph where the vertex was sitting right here? If the vertex is sitting right there on the x-axis, I would have only 1 x-intercept. So that's possible. So I could get 2 x-intercepts, like these, or I could just get 1. So I could have a graph facing up, or I could get another graph facing down. If the vertex is on the x-axis, then we would only get 1 x-intercept. So just 1. Now it's also possible to have no x-intercepts. How, you say? Well, what if I had a graph and it looked like this? It never makes it down there. It never crosses the x-axis. Or I could have a graph down here facing down like this. Again, it never makes it to the x-axis, so those would have no x-intercept. So we can have 2 x-intercepts, 1 x-intercept, or never have an x-intercept. Whereas on these linear equations, we're getting an x and y-intercept every single time. All right, y-intercepts. Y-intercept is where the graph crosses the y-axis, and the x value is always going to be 0. Look over here, y-intercept was 0, y-intercept was 0, the x was 0. So every time we have y-intercept, the x value is 0. Now quadratics are always going to have 1 y-intercept, quadratic functions. So quadratic functions will have 1 y-intercept. How do we find it? X is 0. How do we find the x-intercepts? Y is 0. Just take the opposite letter and plug it in. All right, so let's look at some problems here. 2 examples, and then I get to go home for the weekend. Okay, so first one, I've got y equals x squared minus 1. I want to find the x and the y-intercepts. Let's start with the y-intercept. So I'm going to find my y-intercept. The y-intercept is when x is equal to 0. So all I have to do is plug in 0 for x. So I would get y equals 0 squared minus 1. So this is y equals 0 plus 1. The y-intercept is at 1. What's the coordinates? Well, x was 0, y is 1. There's my y-intercept. Pretty easy, huh? All right, x-intercept, not as easy. In fact, we're going to spend a lot of time in other sections really focusing on how to find these x-intercepts. The x-intercept is when y is 0. So if I plug in 0 for y, I get 0 equals x squared minus 1. All right, well, a little bit harder of an equation to solve. Let's add 1 to both sides first. So you may be looking at this and going, aha, there is one answer. Because if I take the square root of 1 is 1. But think a little bit harder. What number can I square so that I get 1? There's two answers. What can you square and get 1? Well, if you square and get 1, you could have positive 1 or negative 1. So x could be positive 1 because 1 squared is 1, but x could also be negative 1 because negative 1 squared is 1. There's two answers here. That means there's two x-intercepts. Our x-intercepts would be 1 and then the y value is 0. And it would be negative 1 and the y value is 0. So there's my two x-intercepts. Now, how would I know if it's 2 or if it's 1 or if it's 0 intercepts? Well, let's just look at the problem that we started with. So on this one, there's no bx value. So we would know, and then this is a shift down, we would know that our vertex should show up like right here. That should be our vertex because it's an x squared, that's like the parent function, right? And then it shifts down 1. So there would be the vertex, and then the a value is positive, so it should be doing something like this. So that should have told us, oh, there's going to be two x-intercepts on this one. Okay, next one. A little bit different, but let's predict what's going to happen first. Where's our vertex on this one? Well, this is vertex form, so the vertex, our h value is negative 1. Our k value over here is 0. There's nothing there. So negative 1, 0 is right here. This has a positive a value. So it's going to look like this. This problem is only going to have one x-intercept. So let's find our x and y-intercept. We'll start with our y-intercept. So our y-intercept, that's when x is equal to 0. So I'm going to plug in 0 right there. So f of x is equal to 2 times 0 plus 1 squared. So f of x would be equal to 2 times 1 squared. And 2 times 1 squared is 2. So this is 1. 2 times 1 is 2. So my y-intercept, x value is 0. Y value is 2. 0, 2 would be my y-intercept. X-intercept. This is when y is equal to 0. So I'm going to plug in 0 for f of x because f of x is y. So I do 0 equals 2 times x plus 1 squared. Now, I want to get the x by itself, so I'm going to need to do a little bit of math trickery here. I want to get rid of all this stuff one by one. So this is 2 times all this. So if I divide both sides by 2, these would reduce, and 0 divided by 2 is still 0. So I get 0 equals x plus 1 squared. divided by 2, that reduced that, and then 0 divided by 2 is still 0. Okay, so here I've got a square root. So I could do this a couple of different ways. I could just ask myself, well, what does x have to be if I add 1 and square it to get 0? And you might get your answer that way. Like if you have to ask yourself, okay, I need a number right here so that when I add 1 and square it, I get 0. So looking at that, you might say, oh, I think x must be -1 because -1 plus 1 is 0 and 0 squared is 0. So you might do it like that. Or you can undo squaring. Well, what is the opposite operation of squaring? Square rooting is. So you can take the square root of both sides. Square root of 0 is 0. And then square rooting and squaring are opposite operations, so they undo each other. And all I'm left with is x plus 1 right here. Then I subtract 1 from both sides, and x is equal to -1. So my y or my x-intercept there would be at -1, 0. The end. All right, you guys have a good day. Have a good weekend coming up here. Be good. Math hard. See you later.